Alrighty, welcome back. Welcome back to the tour. In fact, let's just jump right in. Tour part 2. Hop on the bus. There we are, ready to continue our tour. So we've talked a little bit about the occipital, temporal, and parietal lobes. And now we're going to talk about the motor cortex. And the motor cortex literally starts here with this strip that you see and goes everywhere forward. This is what we call the premotor cortex itself, a strip along the side of your head. And it literally is the part of the brain that controls the body. In fact, we'll talk about the homunculus. We'll get to meet him in the next chapter. We'll talk about the strip a little bit more. But basically, it represents different parts of your body here. And if I had a little electrode, if I could put a little electrical current into this part of the brain, what you would see is that some part of the body on the opposite side of the brain would move. Okay, if we stimulated this. So it depends on which part of the body this is connected to, but let's say it's our elbow, that if we stimulated the right brain there, the left elbow would move. Okay, and so all of this is associated with different parts of your body. And when the brain wants to move a part, this is the part that sends stimulation to this part, and that moves our body. Okay, so this is directly how the brain communicates with the body. And what we're going to see is there's some planning and stuff that's going to happen here. And then ultimately at the end of the planning, commands will be sent to this part of the brain to go ahead and control the body. So the other primary cortices, when we talked about the other areas, we talked about them as input, where the input comes. But this is output. So the primary cortex of the motor cortex, the primary part, is the primary output cortex. And that's where we control the body as it outputs behavior on the world. That's a big part the frontal is going to do. But of course, it's got to decide what to do first. So yeah, let's just kind of look at it here. And you're going to get this idea of laterality and proportional representation. There's actually two strips that are very similar, and we can talk about them very similarly. This was the parietal lobe. This is the sensory input from the body. This is the the frontal lobe, and this is the motor output. And what you have here, and look at how Broca's is just kind of on the end here. Broca's is kind of the motor output for saying things, for all of this apparatus that we need to produce words. And so that's connected to, so this is where we said temporal, yeah, but it's sort of more frontal. Broca's area is there as well. Okay. So these two strips are kind of similar. One is getting input from the body, from the other side of the body, contralateral, and whereas the other one is producing output, making those parts of the body do something. So getting input from them or actually putting output. But otherwise, they're very similar, and they kind of hang along here. And in both cases, they have this representation of the body. And one of the kind of interesting things about this representation is the amount of brain tissue we have is determined more by the importance of that part. So notice how the hand and the mouth and the face in general are big in this image. They have a lot of brain tissue devoted to them. And that's like, let's talk about the sensory cortex first. Let's talk about getting input. Well, we often use our hands to get input for something. If we're interested in it and we want to touch it, right? And that's where our finest sensory impressions come from. And that's why. And that's because we have a lot of brain devoted to it. I like to do this one for a little bit. Notice that there's not really anything devoted to your elbow here. Pinch your elbow right there. Pinch it as hard as you can. You don't feel anything. Even though you're pinching flesh, now do that to your lip and you'll feel something. All right, because there's a lot of brain tissue devoted to your lip, but there's not much any devoted to your elbow. That's why we can just sit on our elbows, right? It doesn't hurt. So, kind of cool. And this is the same for the input as it is for the output. The parts of our body that we use a lot to manipulate the world, again, our hands are big among those, then they get a whole lot of motor tissue devoted to them to let us do that in a very precise way. Okay, so kind of a cool thing. We call this proportional representation. The amount of brain is related to the importance of that part of the body in terms of either input or output. on the world. Input for the sensory strip, which is the primary cortex for the parietal lobe, or output for the motor strip, which is the primary cortex for the frontal lobe. I keep trying to say these things just so you'll listen and go, yep, that makes sense. I'm with you. Cool. All right. So now let's talk about what the frontal is doing. Not just the motor strip, but the part in the front. And, we actually learned, I told you we learned other things about parts of the brain through neuropsychology, people just happening to get their brain damaged. Well, in this case, we learned a lot about the frontal lobe as a function of a very intentional operation called a frontal lobotomy. And let me just give you, here it's seen as one of medicine's greatest mistakes. The guy who did this got a Nobel Prize, and now we're kind of like, maybe not. But let me give you the story so you understand, first of all. Why would anybody have a frontal lobotomy? I'll tell you what it is, but let's talk about why. The typical situation was this. You might have had a family member in a mental institution because they were constantly aggressive. Given the chance, they would start a fight. They would want to hurt other people. Maybe they even want to hurt themselves. There was a time when we didn't know what to do with people like that. And in fact, in a lot of insane asylums, they were basically chained to the walls, or there's something called a restraining chair. They were kept restrained in this chair, just so that they couldn't lash out and cause harm to anybody. But at some point, somebody came across this procedure. Now, why would they have ever done this procedure in the first place? I don't know. But this procedure took these aggressive, angry people and made them calm, really calm. So imagine, your brother or sister is in one of these institutions, and every time you go there, they're tied down and they're angry and they want to hurt somebody. And a doctor tells you, we can perform this procedure on them and they won't be angry anymore, and they won't want to hurt anybody anymore, and they won't have to be tied down anymore. That sounds pretty good, right? And so a lot of people were electing to have this surgery, which at first was seen as this miracle, until people spent a little more time understanding what they'd actually done to people. So what's the surgery, first of all? It's a little gross. I got to warn you ahead of time. They basically stick a orbitoclast ice pick. Think of it as an ice pick, up through the nasal cavity, up past the eye, so not mucking with the eye, and then swirling it around a little. And they're basically severing the prefrontal cortex, the connections that connect the very front of the brain with the rest of the brain. This is a one-way thing. Once you do it, you cannot undo it. So it's very serious. And so here's a little bit. So Moniz was the guy that started all this. So, let's read a little bit of this. This was considered the beacon that had so transformed psychiatry. The New England Journal of Medicine editorialized that a new psychiatry may be said to have born in 1935. When Moniz took his first bold step into the field of psychosurgery, and when Moniz was awarded the 1949 Nobel Prize in Medicine and Physiology, the New York Times hailed the explorers of the brain who invented this sensational operation. So Moniz, the guy that came up with this at first, was highly acclaimed because it had calmed. These people were calm. They were relaxed, right? So here's some of the claim. Hypochondriacs no longer thought they were going to die. Would-be suicides found life acceptable. Sufferers from persecution complexes forgot the mechanisms of imaginary conspirators. So this is like schizophrenia they're talking about there. Surgeons now think no more of operating on the brain than they do of removing an appendix. It's just a big organ with very different and complicated functions to perform, and no more sacred than the liver. The tale America had been telling itself had wound its way to a wholly satisfying conclusion. Lobotomy was the fruit of a both good science and a humanitarian empathy for the mentally ill. So they really, acted like this was amazing. It was great. It solved all the problems, and finally we had an approach to mental health. Right. Okay. Well, except for the side effects. And there are a bunch of these different. So there are slightly different forms of lobotomy that were applied to slightly different things. Notice that in some cases, the side effects are death, serious personality changes, epileptic fits. In this case, the the patient themselves doesn't really feel they need this, but some people, because they were abnormally aggressive, that's the aggression I told you about, they would be asked to do it. All right. So that was kind of controversial. In other cases, people agreed to these procedures because they were suicidal or depressed or whatnot. Prefrontal lobotomy was a very common one. And this is the one we learned a lot about the frontal lobes from. Okay. So first of all, these were people often with schizophrenia, particularly successful because present functioning areas are disconnected from memories and from future concerns. So there is no doubt when you do this to people, they become very present in the present. So this idea of the memory of the past and the future are largely lost. That's why we, by the way, have serious personality issues here. But yeah, this is what we get. Inability to plan ahead. They don't worry about the future. Indifference to the opinions of others. They don't care what anybody thinks about anything. Childlike actions. Intellectual and emotional flatness. They're not interested in anything. They don't find anything funny or sad or whatever. They're flat. They're very flat. Okay. You may have kind of seen some of the stereotypes of this, of patients just maybe playing cards all day, doing the same thing over and over and over. This is what we kind of learned about frontal lobotomies as they went. And it kind of lets us know what the frontal lobes are normally doing because we see them not doing it. So let's go through these. The slowing of thoughts and loss of spontaneity. Somebody who's had a frontal lobotomy, everything is slow. Everything is slow. And they don't say, hey, I feel like an ice cream. They don't feel like anything new or anything different. They have no spontaneity. They're perfectly happy doing the same thing day in, day out. What's that tell us about the frontal lobes? Well, the frontal lobes seem to push us to try different things every now and then. We get bored of stuff. We go out too many nights, and now we want some quiet nights at home. We have too many quiet nights at home. We want to go out somewhere. The brain keeps pushing us into different activities. Unless we have our frontal lobes disconnected, then we just do the same thing all the time. This one's interesting. Perseveration errors. Do I have my? No, I don't have my example here. So there's something you could look at online called the Wisconsin card sorting task. And what it is a bunch of cards, and every card has some number of items on them. So maybe 1, 2, 3, or 4 items. Those items could be, think of cards, diamonds, hearts, spades, or clubs. So you could have 4 clubs or 2 diamonds or 3 spades. And the color of it could be in one of 4 colors, red, blue, green, or yellow. Okay. And so you could be looking at a yellow with 2 spades on it. 2 yellow spades, or another one with 4 black clubs, okay, etc. And so each of these cards, that's what they look like. And what you're told is you have to sort these into piles. Let's say there's 3 of everything. So there's 1, 2, or 3 things that are either red, green, or blue, and they're either squares, triangles, or diamonds. Okay, so you could sort them based on shape, color, or number. 1, 2, or 3 of them. I'm just trying to get this all in my head. So you see a card and it has all 3 dimensions listed, right? It'll have so many of some shape in some color. And what you have to do early on is try to put those in 3 piles. So you have to guess, I don't know, do I do this based on color? Do I put all the red ones over there and all the yellow and all the green? Or do I put the number 1, the things that have 1 on them here, and 2, and then 3? Or do I put the diamonds here and the hearts here and the whatever here? And so you pick one and you try, and you get told whether you're doing it right or not. And so at some point you figure it out, right? If you were doing it wrong, eventually you start doing it, say, by color, and you're like, right, okay, so all the yellows go here, everything's great. Here's the trick. At some point the rule changes, and so suddenly what was right no longer is right. You're told, nope, that's wrong. And you have to realize, okay, it's no longer sorting by color. I now have to try something different, maybe by shape. And so most normal people take a little while to adjust, but then they realize what the new rule is, and they play according to the new rule. People with frontal lobotomies cannot adjust their behavior. Once they start behaving a certain way, they persevere. They continue behaving that way, even when they're told that it's wrong to do so. So what's this saying? Well, the frontal lobe is helping us adjust our behavior when the rules change. And as we go through life, the rules are different in different situations. And so the frontal lobe kind of makes us realize, hey, you can swear around your friends and they'll think it's cool. You swear around your father, you're probably going to get a swat across the ears. And so your frontal lobes kind of learns, different rules in different places and how to use these different rules. But without that frontal lobe, you just have you got one play, man. That's all you do. You have no ability to adjust. A loss of self-awareness and flat affect, especially empathy. What we mean by affect here is emotional state. They're just flat, okay? They don't seem to even have any sense of themselves. They don't seem to worry about how they look, how they smell, any of that sort of thing. They're very blah all the time, and they have no empathy for others. You can have somebody who's, crying and in a lot of trouble beside them where you and I would feel kind of bad and feel like we should do something. They don't. Doesn't bother them at all. Frontal lobes, again, somehow giving us that connection to others and bringing the sort of joy and sociality to life, but without it, it's gone. Deficiencies in foresight and planning, they don't think ahead. They don't strategize. They don't want to do anything different. They want to just sit here and play cards. And if you tried to tell them, which bus would you take if you wanted to go to the mall, they couldn't do that. They couldn't figure things out. That's what we use our frontal lobes for. And this last one's kind of interesting, a tendency to confabulate. Confabulation is bad lying. Confabulation is when you lie in such a way that everyone knows you're lying. It's just not very good. It's not very clever. And these people will do it, and they can be pushed to do it very easily. You could talk to a frontal lobotomy patient. You could say, tell me about your brother Bob. And he'll say, I don't have a brother Bob. You say, no, you do. You do. You have a brother Bob. Tell me about him. Bob's a plumber. Works for rich people. He'll just start telling a story. And it's a ridiculous story. It doesn't make any sense. No one's going to believe it. But they will do that. If you push them, they will just confabulate. And that's what we call it, confabulating. Lying is being clever. It's trying to deceive. They're not really trying to deceive. They're just going ahead and telling you a story. And they'll do that, pretty badly. And so what's this say again? Well, the frontal lobe says, when we're deceiving people, that's our frontal lobes. Where in fact it's sometimes seen as the highest level, one of the highest levels of cognitive behavior. In order to deceive somebody, you have to kind of have a model of them. You kind of have to kind of know them, and you have to kind of know, if I say this, they're going to do that or think that. So deception is a very complex process, and it requires a lot of strategy, a lot of planning, a lot of memory sometimes of what you've said in the past. And that's all frontal lobes. And when that's taken away, this person is, not, they're not able to deceive, which is kind of good, but it's because they have no cognitive ability to deceive. So at any rate, you get a sense of the picture. A family member brought somebody in to have a frontal lobotomy. They're not violent anymore. They're not angry, but are they anything? Are they just sitting and living now? And so this is why at some point they call this the greatest mistake, because in medicine, because this does not deserve a Nobel Prize. We don't do frontal lobotomies anymore. We would use drugs to help anybody who was overly aggressive. We can do that now with drugs. We wouldn't even consider psychosurgery. But it does tell us a little bit about what the frontal lobes are all about. And in that way, it's kind of interesting. Okay, last thing I'll say to you really quick. Every now and then through the course, I'll mention movies or books you might want to read that kind of connect. And there's one called The Serpent and the Rainbow. It's a fascinating kind of story, sort of like frontal lobotomies, but different. The interesting thing, and I don't want to give you away the whole story, but it's an anthropologist that's interested in this, the feeling in Haiti and other places that black magic is producing zombies. And it turns out when they go investigate it, this was the story, that the black magic priests or priestesses, if you cross them, they would get a drug that you got from a pufferfish, and they would feed it to somebody. And this drug makes you paralyzed. It brings your breathing down so close to zero that a doctor will pronounce you dead. But you're not dead. And in fact, you're still sort of cognitively there, but you're completely immobile and you barely have vitals. And what would often happen is this person would be buried alive. They would be buried in a coffin, but the priests or whatever knew how to do this well. And so a while after they were buried, remember there's some oxygen in the actual casket, they would dig them up and release them. But by then, the person wasn't getting enough oxygen to their brain for a long period of time. And that causes a lot of damage, including to the frontal lobes. But they might still be alive. You know, that primary part of the brain, that midbrain area might still be working. And so these people would now wake up. They could walk around, but they had essentially frontal lobotomies. They had no purpose, no structure. And so what would you do from the community here? Well, you knew Johnny over there really made the black magic people angry. And then you knew he was dead and buried and back. And he's walking around like a zombie. Very powerful. Nobody wants to cross the black magic people anymore once they see an example or two of that. And so this movie kind of talks about that practice and then takes it somewhere completely a little crazy. But it's kind of interesting for kind of thinking about some of these things and how brain damage can impact not just the brain of an individual, but how doing that can then create this whole myth of zombies that's so powerful. Cool. Check it out. Okay, leaving the brain tour there. I will see you. There may be another lecture on this one. I'm not sure if I'm going to have a final lecture at the end. Otherwise, I will see you in chapter 4. Okay, bye-bye.